Hello and welcome to this tutorial on basic statistics from Analytics School Online. Today we are going to learn about histograms. Okay, so what is histogram? It's basically a visualization technique. It's a way how we visualize our data. Now, why histograms? Like, there are various types of visualizations of data. Like, we've got pie charts over here, we've got bar graphs, we've got box plots, we've got tons of column pie charts, scatter plots, and so many more different types of visualizations. But what is most commonly used to represent data in business world or in the corporate world and in many other formats where you actually have to display how your data has worked out and how your analysis has actually been implemented and come out in the end as a result, we mostly use histograms in most of the cases. So let's study about histograms. Now, before studying about histograms, let us understand why we are trying to visualize. Basically, when you visualize, it helps you understand the characteristics of the data much better than what you can actually do by simply looking at the data. For example, when you look at this data set of height and weight of car models of particular cars, you would see that you're not getting a very good understanding of your data. Like, you can obviously observe that with every weight the height is a little less than in all the cases, but when you look at the chart, when you look at the actual visual implementation of this data, you actually observe a pattern that for particular vehicles there is a great deal of variation between height and weight, and for others there is less variation, and simply and with more complex data sets you can actually derive much more results from simply looking at the data set. There can be many inferences you can derive by simply analyzing a plot of your data without even implementing mathematics or without even computing anything with your data. It actually also enhances the viewer's interest in listening to your report. It actually engages him and throughout the entire presentation that you're trying to make. In business and corporate worlds, this really helps. And finally, the images are actually very well received or recepted in your brain, and you can actually recall and remember much more from the images than you can actually remember from looking at text or numbers. So let's start with histograms. Let's look at some of the examples of histograms which we have here. Now, this is an example of histograms. You can see the x-axis and the y-axis. Again, another histogram with x-axis and y-axis. These two are pretty different, but we'll study the characteristics and properties. Looking at the histogram, what do you observe? Let me show you. The first thing that you observe is that you only observed numerical data. So basically this is only a quantitative plot. Sure, you can convert your qualitative data into quantitative data and you can again plot them. So that can happen. But if there is a histogram plotted, the data must always be significantly quantitative or numeric. So looking back, you can see there are actually no categorical data or no form of attributes. Everything is numerical in the x and y axis. So that was our first observation. Second observation is that our observations and the plot is continuous. It actually has no gaps. So basically what it's trying to say is that in this histogram or this, what you see is that between any two intervals in the x-axis there is no break in the y-axis. Like, there is no gap between these two observations or any observations. These are all concatenated together and are in a continuous format. Moving on, the bar width is variable. Now, bar width usually is constant. In most of the cases which you will see, the bar width basically is the difference between the lower and the upper values in a particular interval. It is mostly constant. You can see here it's constant, here it's constant, but here it is not constant. Well, this is actually an unusual case which we'll get to know in this video later. But just for the sake of understanding, you must not always believe that the bar width is constant. It can be variable. Many other students believe that it's always constant, but it's not so. Moving further, x and y axis are distributions of data, sometimes range and sometimes frequency plots with ranges. not necessarily regular. Now what this means is that X axis is basically a range of data. Like this data is ranging from 0 to 100, this is ranging from 0 to 100 again, this is ranging from -4 to +4. So again, the numerical data can also be negative. It is not restricted to only positive data. It can be negative. And y-axis is basically frequency oriented. Like for example, in this histogram plot, in the interval of 10 to 20, there is a frequency of 10 of the number of students who have actually had points between 10 to 20. So y-axis mostly in histograms is basically frequency oriented, or they mostly plot or use frequencies. And finally, the overall symmetry is not necessary. It might display skewness in data. Like for example, here when you look at this data is fairly symmetric. The highest value is between 50 to 60. It increases from 0 to 10 and it again decreases when it reaches higher numbers or 90 to 10. But there can be skewness. Finally, moving further, let's observe a simple histogram one by one. Now this is a Excel table of 2 columns. The first column is the months column. It actually contains the month interval, the span of 1 month from 1st January to 1st February, and this is the number of products sold for a particular company. So the products in thousands, so this is 156,000, the observation or the data value. So what happens is that this column of months and this column of numeric products sold can actually be presented in a histogram format, and once we look at the data, we can actually create many variations. Like these numbers actually are not by default, these are special creations in Excel. We learn it in the Excel implementation of histogram plotting in our next video. But for now, basically our x-axis says months and our y-axis says sales data. So that is what it represents. So once you look at the plot, you can actually understand that in the month of January we actually sold 156,000 units, and in the month of July we actually sold 523,000 products. And finally, you can actually observe the overall symmetricity of the data. Like this data set is actually symmetric, and just to actually negate the concept that you actually created in your mind, you can also have non-numeric data or categorical data in your x-axis. That is true. What we actually learned from these histograms is that our data must always be numeric, but that is not true. We only observe numerical data in those examples. There can actually be non-numeric and categorical data in your histogram, and that is possible by simple implementations which we are going to learn. Moving on further, now histograms can be classified into 3 types. They can actually be classified into various kinds, but based on skewness or symmetricity, we can classify them into 3 forms. Now one is symmetric. Now in symmetric, our data has a regular increase and regular decrease in the whole span of our data. And then comes the positive skewness. Now in positive skewness, or in a positively skewed data set represented on a histogram, most of your observed values or highest frequencies are skewed in the left direction. They occur early in the interval of the x-axis, and opposite to positive skewed data is negatively skewed data, where most of your high frequency observations lie towards the end or after the 50% of the interval of the x-axis. So in negative skew, your highest frequency lies after the 50%. In positive skew, your maximum frequency would lie before the 50%, and in symmetric data, you will actually have your maximum frequency in the middle or in the center of your data or the histogram. Moving forward, you can also classify histograms on basis of distributions. Like there can be different types of distributions. I have only displayed 3 for the sake of simple understanding, because this is not a tutorial on distributions, it's actually on histograms. So I was just trying to explain you that histograms can be plotted for various types of data. For example, this is an exponential distribution, and the histogram beautifully shows the exponential decrease in the observations or the frequency for this particular data set. Then there comes the normal, or you can also find this kind of distribution in the binomial data sets. A systematic increase in your observed values or frequency values, and then a systematic decrease with the maximum frequency or observation being at the center of the data set. Because this data set ranges from negative to positive, it actually must lie on 0. So this is the observation with the maximum frequency, and it's also symmetric data. And moving further, there can be many other plots of single peak or double peak, which is also called bimodal, where there are actually two high frequency ranges where the observed values actually decreases, increases, again decreases and increases. So actually it increases 2 times in one interval of the x-axis. So these are also some types of distributions which we are going to study later in this course. So let's get to the basics. How do we create the x-axis in a histogram? Now the x-axis in the histogram is very specific because we want to make it a continuous data, or we want to have x as a continuous range of values. We actually do something special. When we consider plotting the observations or the frequency on the y-axis with respect to the x-axis, in every interval of the x-axis we actually include the lower value or the lower bound of the data, and we exclude the upper bound of the data. So in this range of 70 to 80 in this x-axis, if you try to plot a particular frequency which you get from the data that you observe, you are actually not going to consider the value 80 inside this frequency bar that you create. You would actually consider 80 in this range of from 80 to 90, and similarly you do not consider the upper bound when you plot on the y-axis with respect to the x-axis. You only include the lower bound and the whole interval except the upper bound. Just as we learned for the x-axis, we now learn for the creation of the y-axis. Once we get the total number of observations or the total number of values, the frequency in between the range of 70 to 80, where we actually include 70 and exclude 80, we simply create a rectangular bar which stretches from the x-axis between the interval values to the height of the actual frequency based on the y-axis plot, and that's how we simply create the y-axis. Now there is a coined term called bins. So bins is basically the series of continuous intervals that the whole range of data is divided into constantly. Now constantly is actually not the right term to use here, because it's not always the case. There can be bins of different sizes, but for the sake of understanding and a basic histogram knowledge, we are considering the width of the bins to be constant here. And what we try to understand from bins is that the higher the number of bins we have in our data, the better visualization and better precision we have by looking at the data. For example, you can see that for the same data set, I've plotted 30 bins for this case, where you can see that there is a great deal of precision in the individual observations that we are having. Then I've plotted this for the same data with 15 bins, where you can see that you can actually visualize the data really well, but not as precise as you actually did with 30 bins. And finally with 5 bins, the value is very distorted. You can actually not understand the individual frequency values for every single interval. It is very generalized, and this is actually not what we want as a data analyst. We need more precision, more accuracy in analyzing our data. So that is our bins. Now let's understand how we calculate the value of our bin size or the width of our bin size. It is a very simple formula. You simply subtract the lower value of your range from the highest value of your range, the lower bound from the upper bound, and divide it by the total number of bins you want. Now the number of bins will actually improve your visualization and precision, so you might want to actually pay attention to the optimization of this value, the number of bins that you have on your histogram. Highest value of range and lowest value of range is very basic. Actually, you just look at your data set, you arrange it in an ascending order, and you get the lower bound from the lowest value of your data set observation and the highest bound from the highest value of your data observation. And just to give you a random example, if x is spread between the range of 20 to 1465 and you want the number of bins to be 25, you can actually work with many more examples and many more variations with the number of bins to actually get the optimized best visualization of the histogram. Let's say for example it's 25, so you calculate the bin size by actually subtracting 20 from 1465, which is your upper bound minus lower bound, and divided by the total number of bins, which is 25, and you get a value of 57.8. so basically you're going to have 60 as the width of your bins. So for example it would start with 20, so the next interval would be 20 plus 60, that is 80. Then again you add 60, so it would be from 80 to 140, 140 to 200, and so on till 1465. Finally, you've decided how you divide the intervals of x, but how do you divide the intervals of y? Now this has a lot to do with practice. The more you practice, the more intuitively you understand how you're going to actually divide your y-axis in various intervals. So we can just practice more, think wisely and intuitively, and understand what is our variation in y. And finally, the ripe fruit of your sheer hard work in creating a histogram, you actually can create it, and we are going to learn it in the next tutorial in the Excel implementation of creating a histogram. But this is going to be your final output, where you're actually plotting height versus weight for cars, and these are the values of frequency, where most of the values, like 48 values, range between this interval. We'll look at it in the next video. And finally, there is a lot of other fun and interesting things coming up in this basic statistics, so hold on, learn and grow with us. See you soon. We'll be right back. Thank you.